Here in this video, we are solving a question basing on thermodynamics given in NEET 2020 and a relevant question in 2018, both based on the heat engine. So the question is, so to understand this, though I can directly write a formula, but I'm telling you that how does it works actually so that we can understand easily. What does the heat engine do is, in heat engine broadly there are three parts. There is a source, it supplies heat, has a particular temperature, that's called temperature of the source. This supplied heat will try to do some work. Some work is done. After doing the work, some heat is rejected back to the surroundings, and that part is called as sink. That will also have some temperature T2. So what we can say broadly in terms of energy is heat supplied from source has done two jobs. Some external work, and then some heat is given to sink, rejected to sink. So how do you measure how efficient the system is? We can simply measure it as the work that is done with the help of the supplied heat. So dW, work done, supplied heat, dQ. But I can say total supplied heat is work done and heat rejected to the sink. Heat given to sink. So dW can be written like heat supplied from the source minus heat given to the sink, that is dW. So I can write efficiency further as that implies in place of work done, heat supplied from the source minus heat rejected to the sink by heat supplied to the source. If you say heat is directly proportional to the temperature, if you consider that as the temperature of the source minus temperature of the sink by temperature of the source. That's 1 minus T2 by T1. All these temperatures shall be taken in absolute scale, Kelvin scale. That's the formula for the efficiency of a heat engine. Taking that into consideration, now look at the first question itself. The efficiency of a heat engine depends on temperature of the sink only is not correct because it depends both on temperature of the sink as well as temperature of the source. Temperature of the source and sink is correct. Third option, the volume of the cylinder, no, it doesn't depend on the volume of the cylinder. It doesn't depend on the temperature of the source only. So the answer is it depends on the temperature of source and sink. That's the right answer. Answer B is the right answer. That's the first question. We can easily solve the second question also. Look at the next question. The efficiency of ideal heat engine working between freezing point and boiling points of water is how much? I can write as we have written the formula just now. Efficiency is 1 minus temperature of the sink by temperature of the source. Temperature of the sink is freezing point is 0 degree centigrade, that is 273 Kelvin. And the boiling point is 100 degree centigrade, that is 373 Kelvin. That is 373 minus 273 by 273. That is 100 by 273. If we calculate, it comes as 0.268. Percentage of efficiency means you have to multiply with 100. Then that becomes 26.8%. So its efficiency is 26.8%. So to solve these problems, we need to know the basic concepts of working of a heat engine. I have explained it and I have derived a formula also to make job little more comfortable and independent of any of the other variables. That's it, and thank you for watching.